Okay, we have looked at electrolysis of your molten binary compounds, your molten ionic compounds. Right now we are looking at the aqueous ionic compounds. So aqueous, remember AQ means there is water. It dissolves inside water. Okay, so in solution, your water breaks down into the plus and minus, your H plus and OH minus. Okay, NaCl will dissociate as well into Na plus and Cl minus. So just now, right, when we are doing molten compounds, there's only these ions to consider. So it's very straightforward. But now, right, when we are breaking down the aqueous compounds, there are these 4 ions to consider. Okay, so when there are more than one type of cation and anion, we have to do what we call preferentially discharge based on position of the ions in your electrochemical series, the concentration and the type of electrode. So let's look at A. What is the position of these ions in the electrochemical series? Okay, so the electrochemical series is nothing new. This is in fact just your metal reactivity series, just that we don't say metal reactivity series, we just say it is electrochemical series in electrolysis. Okay, so more reactive metals, they lose the electrons easily, so they will remain in solution. So what are your reactive metals? Sodium, potassium, all this. Okay, remember this one. Popular scientists can make a zoo in the lab, however, cannot make silver gold. Okay, so metals that are reactive, they will remain in solution. Less reactive metal, it is harder for them to lose the electrons. Okay, so it is harder for them to lose, so maybe they will try to form metals by itself. It will not form the ions. It will stay as the metals by itself. Okay, so how do we see? We compare it always with your hydrogen ions. These metals above are never discharged. Why? Because they are higher than hydrogen in the electrochemical series. And why am I concerned over the H plus? Because it's aqueous, and aqueous, it breaks down your H2O, breaks down into H plus, OH minus. So if I'm comparing it with the H plus ions. Okay, and then the ease of discharge for my non-metals, your polyatomic, your sulfate and nitrate, the polyatomic, they are never discharged. Because they are more reactive, they remain as anions. Okay, and then if we are talking about your group 7, so group 7, which one is more reactive? My fluorine is more reactive than chlorine, more reactive than bromine, is more reactive than iodine. So which one will get discharged, right? It will be according to this reactivity series, right? Your iodide ion, your bromide ion, your chloride ion will tend to get discharged in this order. Okay, hydroxide ions are the least reactive. It is the easiest to get discharged. Okay, so anions, your polyatomic ions will never get discharged. Your group 7 one, it will depend on the reactivity of your group 7. Okay, hydroxide ions is the easiest to discharge. So for metals, we choose anything that's below hydrogen. For non-metals, always through the hydroxide if there is. Okay, and hydroxide ions, when they get discharged, they will form oxygen and water. Okay, so when we write your equation, you have your hydroxide ions. Okay, hydroxide ions, it will form O2 plus H2O. Memory work, you have to know this. Okay, the O's form O2, the H forms H2O. Okay, balance out your equation, right? You balance out your O. There's 2 here. So total, there is 4 O, so put a 4 in front. Okay, so when you put a 4 in front, your 4H balance out with the 4H on the right side. Okay, so there's 4 negative here. So this part is neutral. This oxygen is neutral, water is neutral. So you must add 4 electrons here. Okay, and that is how we get your half equation for your hydroxide ions. Okay, be able to write out this equation on our own. The memory work is hydroxide ions will give me oxygen gas and water. Okay, in an example where I perform electrolysis on aqueous and dilute sodium chloride using inert electrodes. Okay, so same idea, we can draw out the setup. Short end, this is negative. This is positive. Okay, let's write the same idea here. Your negative ends, your cations get attracted. Is the cathode. And reduction takes place because recap. Okay, and reduction is gain. So cations, what are the cations that's inside my aqueous sodium chloride? So aqueous, as you know, there's H plus and there's OH minus. Then sodium chloride, there's Na plus and Cl minus. So what are the ions? Write it here. Na plus, H plus. As a habit, write it. Okay, so same idea on the other side. This is positive and this is my N ions get attracted is the anode. Oxidation takes place. And oxidation is loose. If you write all these steps down, then you can definitely get your answer. So what are the N ions over here? You have your OH minus and your Cl minus. So based on what we have learned just now about preferentially discharge on the electrochemical series, right, we will circle what are the ions that are preferentially discharged. So sodium, potassium, popular scientist is your sodium, yeah? These are high up in the electrochemical series. So they are never discharged. They are reactive, they remain as ions. So we circle your H plus. H plus gets preferentially discharged. Let's write it. Hydrogen ions gets preferentially discharged at cathode as it is lower in the electrochemical series than Na plus. So what happens? H plus gets reduced to H2. Okay, how do we write the half equation? My H plus electrons give you H2. Write in your state symbol, yeah? Okay, so reduction is gain. H plus gets reduced. Everything ties up together. Okay, same thing over here. So let's look at our anions. Just now we conclude that there's the hydroxide ions and the chloride ions. Which one will get discharged? Always select the hydroxide ions since it is diluted. Okay, so how do we explain it out? It's the same idea. Your OH minus is preferentially discharged at anode. Okay, it is lower in electrochemical series. The OH minus gets oxidized to O2. And then let's write our half equation where my OH minus will form oxygen and water. Balance out your equation with a 2 in front to balance out your O, to partner out all your O, put a 4 in front and 4 electrons. You gain electrons on the right, means this part you're losing the 4 electrons. Oxidation is loose, everything ties up together. Okay, so this is how we break it down, and then we write the ions. Okay, circle the ions that get discharged. Explain it out. Okay, write your half equation. Okay, so after you write your half equation, the product, oxygen gas, hydrogen gas, your observation, what we see, effervescence of colorless, odorless gas. Effervescence of colorless, odorless gas. This is standard. Okay, write your full equation. You must make sure your electrons balance out. Okay, so you will have 4H plus, 4OH minus. It should give me 4H2O. Okay, give you oxygen plus 2H2O plus 2H2 gas. Okay, so 4H2O and 2H2O, 2H2O cancel out, this one put a 2. Right, so you have your overall balanced equation here. Okay, so question of the day is what is left behind, or what is the effect of your electrolyte? So since I cancel this and I cancel this, what is left behind? I'm only left with NaCl. The water component is being electrolyzed, right? It is being discharged. So the concentration increases. So from a dilute salt solution, you can get a concentrated salt solution. Okay, and then note 2 volumes of hydrogen gas are liberated for 1 volume of oxygen gas, right? Because your balance equation is 2H2 is to 1O2. And this one, 2 is to 1. This one is for dilute aqueous salt solution.